Alright, so we're going to do our electrical section of the installation, which entails quite a few things, but initially we're going to do a little bit of prep work to get ready type of thing, which means we install this shelf between the bottom part of this firewall stringer and the brace for the windshield on the airplane. Now that you have lots of leeway as far as what you want to do. You want to make a shelf on the entire thing, which we normally do. This is kind of kept open for future expansion by the owner, so his wishes. So that's why we're going to be doing this area for the engine, and this will be more for avionics and things like that. We built a shelf just from some scrap aluminum. Got some angles and riveted to the sides, some A-dowel clamps to attach it here, a couple of AM3s up front. So whatever you got around the shop. I would say the only thing to watch out for structurally would be when you drill these holes that they're, you know, at least halfway or more in from this edge, so you don't remove the strength of the edge of this stiffener. So they have to be, but other than that, you're not doing any structural changes to the airplane. We also put a hole over here for the nylon pass-through. The nylon pass-through comes in your firewall forward kit, and so you would basically just kind of line it up on the outside there and find out about where you want it. You know, check both sides, make sure you're not going to hit a stringer on the back side. Find out about where the center is, remove it, take a carbide hole saw and of the right size and just pop that hole. You want the hole as big as you can make it without breaking into the 4 mounting holes that also mount the, this is a 2-piece unit, so eventually you're going to be able to put it together like that. And there are even little holes here for tie wraps. You'll see that when you get it. It's not really necessary to use them. Kind of makes it nice though because it holds it together. Then take your computer snake or cord, harness, and carefully fold the wires lengthwise on the connectors and feed them through sideways one at a time. Prior to doing that, deburr the edges here so it's all nice and smooth, because the last thing you want to do is cut some of the wires for your computer harness as you put this through here. Once that's done, then we're going to find a place to mount the computer. I have a thought on that, and we're going to get back to it, but I also don't want to take up our nice shelf for the computer, so we will take a look as we go along here. We started with the batteries. First we put a little protective sleeve on this sharp edge here, behind here, and then we set the batteries up against it. We decided to hold them down with just 3 of these brackets that we just happened to have in stock for something else, and that obviously keeps them from moving side to side, front to back, whatever. And then our little bridge here, we figured it might be hard to get in here once this is all close, so we just made something where you disconnect this, you can push this through the firewall and put a little blue Loctite and a wing nut on here, and that'll keep them safe. So that's, we also oriented the batteries in a particular fashion. We put the positives over here and we put the negatives over here. We also then, based on that, had our positive inside of the contactors close to those. We put our positive bus here so we can join the outputs and bring them directly to that. We can also come through here for our starter cable, so that's kind of makes it pre-planned for where the cables and wires are going to go once we start stringing wires between these things. We also installed our negative bus over on this side, and again it's close to the negative posts on the battery. So we're going to go from here to here and from here to here. We did mount our computer. We had some rubber standoffs for that. Those are available from like McMaster-Carr. They're basically just rubber standoffs with threads at both ends. They're fairly common. Military surplus stores, anything like that would have those kinds of mounts. We mounted it underneath, then we removed it to do all of our drilling, and then now we just remounted it, and we have a nice direct run from our pass through here, and then right to the computer. We also have the ECU in a way that if we ever had to return to ECU, to Viking for our ECU update or something, we could very easily reach underneath the panel, disconnect the cables, and send it. We also mounted our switch panel. This is a pre-assembled panel that Viking sells. This one has a Viking view opening for it. This can be cut off, and in this case it might be because it'll have different instrumentation. It also then has the switches required to run the engine, such as your battery master 1, battery master 2, alternator on off, fuel pump and fuel pump 2, and then this is for basically the rest of the airplane. 25 amps is what the rest of the airplane gets. So everything we're making up front here is for the purpose of feeding the engine and keeping the engine running. The only place where there's going to be power to the rest of the airplane, meaning your avionics, your lights, all this stuff, your coffee maker, seat warmers, whatever, is going to be this switch here, and that's got the 25 amps. That way, when we flip this on, everything else comes on, or at least you're powering up a separate bus that you were going to mount somewhere here that then powers everything else. The nice thing about that is that if anything shorts out in the airplane anywhere, this 25 amp breaker will then trip, or a breaker downstream of that, a 2 amp breaker, a 3 amp breaker, or something that is the safety for your lights, for your avionics and all that. But the 25 is the main breaker that feeds the rest of the airplane. So now that was the quick rundown of the basic components. Starter relay we didn't mention. And now we're going to go back and start stringing one wire at a time and show you how that's going. Okay, so we've added 2 more items, a junction block, and we'll show you what that's going to be for, and a set of items, so actually 3 items total, positive and a negative pass-through for the ground, and positive leads that are going to go to the alternator, starter, grounding the engine, and so forth. So there we are.
So, I didn't put a mask on when I went to the ice cream.
Right, go ahead.
Okay, so we did string 2 ground straps. We'll show you how to crimp terminals on the next cable that we make, but it's the same procedure. So we have the 5/16 holes and the -6 lugs, 2 of those. We have 2 ground straps just for redundancy, and they run in this loom. We have them hanging kind of off the engine here, and then they come up here, and there are 2 bolts that we use, one here and one here. We do use a different kind of a lug. It's well, different size. It's still number 6 hole in the lug to pass the cable through and crimp it, but we use a 1/4 inch hole for where the 6mm bolts go in. And that's it. So we've got that installed. We showed you how to do the pass-throughs. We also did the air filter at the same time. Basically, with the 750 style airplane, the engine mount runs right here, so we have to kind of come over with this 90-degree elbow. On a 650 type of airplane and some other airplanes, this part of the mount is not here. There's a cross brace, but it's further down. So we don't need this. The filter can then go directly onto the throttle body of the engine. With the silicone elbow, you want to trim it, especially the side that goes in here, so that it doesn't get pushed this far too much. You trim the elbow with a razor knife. And you can trim this side too if you want the filter in a particular spot. But we only trimmed the part that went on the throttle body. We clamped that down, and we clamped a little spacer that goes in here that comes, a little aluminum spacer. We clamped it here, and then we clamped the filter to the spacer. Making up a couple of more wires. Follow the procedure. If it doesn't strip on the right one, go to one that's smaller. Be careful that it doesn't eat into the wire. That one there is just a little bit loose too. So now we're going to go to this one over here and give it a shot. I could feel that it was stripping a little bit of metal. Again, it's the problem with the tough cell wire. So I'm going to cut it with that one. Oh, this time it worked fine. So if we keep it nice and square to the tool, our number 18 works just fine. And that's good because it's an 18 gauge wire. So in this case, it's working just absolutely perfect. We take out 3/16 or so on each one, 3/16, maximum a quarter. And then we're going to have this is still a red terminal for the smaller gauge wire, but it has a pretty large hole in here, and that's because when we measured the lug on the contactor, that's what it needed. Set this up so you can see the wire going through, about 1/8 of an inch or so. Not so much that it's interfering with the hole, and put it in the red area of your ratcheting crimper and crimp it. Ring terminal on one end and the fast on terminal, they call these guys, at the other end. And then that's one, and then we'll make up another cable just the same. Ring terminal on one end, and a fast on terminal on the other end. And then we're going to bring these to the plane, and we're going to put them in place. We're just going to measure the length of the cables, only because my cables are over on the shelf. If it wasn't, I would just use too much cable and trim it as I went, right off the spool. So we're going to need a We're going to need a 30-inch cable for the starter. So we're going to make him up on the table. One side would have a 5/16 lug that's going to go on here, and a 5/16 lug there. So that's a simple one. Alright, to make your cables, there's not a whole lot of cables to make, but you do have the ground straps we already installed. And then we have now a piece of starter cable wire, number 6. So basically a stripper or stripping tool like this one is too small to do the big cables. So what you end up with is a knife, and you carefully then just take 3/8 of the end as far as the distance from the end. You lower the knife through the teff cell and just kind of roll the cable or move it to the side, and then just kind of push gently, because obviously the only thing you want to cut is the teff cell and not the cable itself. And turn the knife this way and slice it, and then you can get your fingers in there and just peel it off like that. And then you do the other side the same, about 3/8 from the end. Kind of roll the cable, push down until you don't want to really slice, you just want to roll the cable and push down like that. It's kind of the safer way as far as not. And there are tools, I'm sure, to do this if you're doing 1,000 cables, but you're not doing 1,000 cables, so this is how you do it. Then you take your lug and install it. Make sure you get all the strands inside of the lug. And there are different kinds of squeezers. This one we're going to use the 3/32, the middle one, and just center it on the lug front to back. Then you get a nice flare of the lug up on each side, and that gives you a nice crimp that you can trust. You know, you could hang a walrus from that. And then we're going to do the other side, just like that. I guess you can't hang walruses anymore, they're like protected, right? Alright, so then you do the other side, same, crimp it up, and then you got a cable. Now some people are real big on putting shrink tubing everywhere, and I'm not really, because I want to be able to see my connection over the ears. If you do use shrink tubing with like adhesive in it or something, that's fine. The thing about this installation, and we're going to talk more about that at the end, is that once you turn the batteries off, there is no current anywhere. Like if you have your contactors off for battery 1 and battery 2, you can work out inside on the engine and there's nothing that's hot or that has 12-volt power. So if you've got a wrench or something stuck on it, it wouldn't arc as long as the batteries are off. And anytime you would be working on your engine, you would have the battery masters off. And if they were on, you would know about it. So that's my philosophy, and we stick to that. So we're going to show how this gets installed on the aircraft/engine. All right, so we have a pre-made cable with the split loom on it. This is the high temperature loom. Usually has a gray or a blue stripe on it. We're going to feed that through behind the engine here, and I'm going to bring it up to the we're going to obviously clear like the pulleys and the belts and all that, and we're going to go up to the positive terminal going through the firewall. I'm going to go underneath this here. It looks a little bit better, I think. And we'll tie that all in as we go. On the starter, I'm going to turn this one like upside down like this, because there's another, I'm going to spin off this 12mm nut that's back here. There's two of them. One is permanent on the starter. The other one is going to then is permanent on the starter, and then this goes on there upside down. And what that does by putting it that way is it allows me to put another cable on top very easily, and that one is going to go down to the alternator. So we're not going to put that nut back on yet until we get the alternator cable on. Instead, we're going to work on bringing the cable up here and bending it so that it fits properly onto the terminal up here. Cable made up for the alternator with the high temp loom and both ends. We're going to put one end up to the starter, and since we now have one terminal laying this way, we're going to flip this one like this so that when it goes on it doesn't interfere with the one that's already on there, since we're putting two on there. So that's it, it's already on, and then we're just going to take the nut and get it started like that. Alright, that's pretty, it's kind of a little tight back there, but it's not too hard to get that done. So let's just complete that job. Let's get our ratcheting wrench and tighten that down so that we don't have to come back to it. Okay, and then at the alternator, we're going to do some tying up of this cable as we move along, but for right now I'm just going to install it. One important thing about the alternator cable is that because the alternator is kind of hanging off the engine a little bit, it has more vibration out here than the center of the engine. So we cannot rely on putting a cable here and then let it just kind of dangle into vibration. So we're going to plan on having an Adel clamp right here as soon as it leaves there, and it's going to hold it so there's no vibration on that lug. And then we're also going to tie it off back here, and we're going to tie it here. So first thing is just to put this on, and I'm going to leave that just a little bit loose so we can move this around until we get the Adel clamp on here, and then we'll look at all these other things where we're going to strain relieve. This yellow and black cable, if that's present in your harness, then yeah, it just goes in with this, and that gives power to, so that you can have a light inside the cockpit if you want that. Most EFIS systems don't need that anymore. You don't need a warning light from the alternator, but it's present if you need it. Alright, so we'll put some strain relieves on here, some clamps and things, and then we'll film that as well. We got the alternator cable in, and we put a strain relief here, or a support I should say, and we tied it to this bracket here with some zip ties. We also put a dowel clamp here. We actually installed a longer bolt right here to do that. We're going to start doing that production. So engines leaving now will have this longer bolt, and you can put that there. So now we only have like 2 inches of unsupported wire here, which is perfect. So now the current from the alternator will exits here, or this is where the charge is generated, of course, in the alternator, and it will go from here. It'll go to the starter, just because we need a junction point, and then it goes from there, and it goes through the starter cable when it's not used. Obviously it's not starting the engine after it's running, and then it'll come through here, and we're going to do the inside wiring of bringing the alternator charge to the batteries, and we'll put that in the next little clip coming up here. We pulled out the trusty wire diagram from the Viking website, and we started the individual wires from point to point. We've got our positive here and our positive there on the 2 batteries. So we crimped and made 2 little jumper wires. One with the size that fits the tiny little screw on the battery, and one with a 5/16 slug over here. And while we were at it, we went from positive to the input of the contactor. Has a little plus sign on that side of the contactor, and we did the same on the second battery, from the positive side to the input side of the contactor. Then we looked at the wire diagram, and we found that the diodes that go on the contactor to suppress any kind of spark that might happen inside the coil of the contactor, we added 2 diodes, one for this contactor and one for the other one. There's a stripe, a silver stripe on the diode, and it goes towards the input side of the contactor, and the other end of the diode goes to the little lug here that eventually we're going to ground, and it is used to close the contactor, but we'll get to that later. So to this point we have added 2 jumpers of number 10 wire, and a contactor on each, a diode on each contactor. All right, 2 more wires to make this all work. These are important. Every wire is actually important. Now we've got the first two switches here are master 1 and master 2, meaning that this one or this one can close the contactors that energizes either battery 1 or battery 2. So we've got a wire made up from here to our grounding bus. We're doing another one on the second switch, and it's also going to go to our grounding bus. Now, if you look at this, I like to do them this way. Minor little detail. You can put it this way, and then there's nothing really keeping this from rotating or turning. But if you flip it over and it lays against the edge of the bus, it kind of just stabilizes the terminal. So sometimes that works and sometimes it doesn't work. Now, don't drop stuff on the ground. I also like to grab some split washers or lock washers and just kind of add those to the critical wires on the terminal strip for extra precaution. So we got the 1 wire on, and we'll do the second one. As far as like how tight do you tighten these, well, you snug everything down, and then on your first inspection you go back and you just kind of make sure nothing is loose. So we're not going to go crazy. It's snug now. Just a tiny bit more, and then we're going to go on a regular basis and verify that everything's tight. So that's one side of the 2 first switches, and that is to get ground into the switch, and then we're going from here to the contactor, and the same one on this one to the contactor. And as soon as we do that and we supply ground to this bus, we will be able to close those contactors. But next thing, let's put a wire from each one of those to the contactors. The switches that we just grounded for master 1. We're sliding our fast on terminal on, and the same with the second one. We might as well just do both of the switches at the same time. What we're going to do with our shelf here is we're going to wire underneath it. We can always tie the wires a little bit at the end, but what it does is it allows us to have a nice clean shelf on the top here. So one of them is going to go here, and one is going to go to the other one. And again, we're flipping it upside down so that we get a nice flat clean surface on top, and we can put the lock washer and the nut on. And now we are actually almost ready to make some clicking sounds from these solenoids. The only thing that's left to be done to get to that point is we have to put ground from here to here and from here to there. So I'm going to snug these two nuts up here. We've got the lock washers on them, and once that's done, the next step we're going to work on is to ground the battery to the grounding bus. We added 2 more wires or cables from the negative post to the negative bus bar, and from the other negative post to the negative bus bar. We're going to tighten this one and this one up because they're complete, but we are going to add another wire. This will be a heavier duty wire, a number 6 cable, and it's going to go to our grounding lug through the firewall, and that's because we need this extra beef in order to be able to start the engine. So that's going to be made next. Alright, we just finished installing the number 10 cable here and the number 10 cable here, and we then added a number 6 cable from the ground through firewall terminal here over to the ground bus over here. We also added lock washers to everything on the buses just for extra precaution. After we got that grounded, we now know that since we're using both batteries for starting always, these 2 number 10s will supply the grounding bus, which will then supply the number 6 cable out to the engine. On the other side, we have 2 number 10s as well, and they are supplying individual power to each contactor. So when we close both contactors for starting, we have full amperage available at the output side of the contactor. Basically, a number 10 and a number 10 is almost like a number 7 cable. So we do use smaller cables, but since we're always using both batteries for starting, we can use the smaller cables and have the full capacity at the output side of the contactor. As you can see, we also made a number 6 cable here from the joined contactors to the through firewall terminal, which on the other side has a cable to the starter. You can make up another cable like this between these 2 contactors, or if you have access to, or a local hardware store or some place where you know you can purchase a brass or copper bar, you can do like we did. We added a copper bar where we drilled 2 5/16 holes, and we put that across, so we tie them together with the copper bar or the brass bar. We're going to continue on with the output power from the 2 contactors. We've already done out to the engine to start the engine. We're now going to jump from here to our positive bus, and then that supplies power to the computer and the fuel pumps and the associated things with the engine. Yeah, you can flip this one too.
Yeah. Wow.
Sideways, like straight up.
No,
you're right. Just like this.
up and down.
Yeah. because then it'll leave the edge and it'll be perfect.
Okay. Making sure I want to do it to the beyond standard
Oh, you got it.
as I drop the. I guess it also helps if it's the right one.
You just have to be just snug enough that you compress the lock washer.
Got it.
We might not use this side, but we'll leave this on there just in case it ever gets used to jump over to an aircraft bus
Okay.
from an engine bus. Snug that up a little bit.
So you tell us what you did?
Let me borrow that. All right, we're still rolling, or?
Yeah. Wait.
All right. So the only thing we've done since the last time we visited this was supply power from the output of the contactors to the main power bus for the engine. So this will then supply power to various switches such as fuel pumps and the alternator. And that's what we're going to start with next. All right, so we just wired the starter solenoid, and one of them, the black one, obviously went to ground over here. The blue and the white's already been wired into the pre-wired bus from Viking, or you can just a wire diagram and do your own. The yellow, and this is the reason for a terminal strip. The yellow is going to the terminal strip. A terminal strip is not connected like these are. These are bus bars where everything is connected. These just go right through like this. So when we put the yellow wire on the terminal strip here, we can attach something right across from it and voltage will go through here, and that's what we want. Basically it's going this way. So we're going to attach to this side the starter solenoid wire from the engine, which we're going to find in the bundle of wires that come with the engine. So we're going to unwrap this, find the right wire, and it's going to go right here for the starter solenoid.
What color is the wire?
It's going to be labeled right on here.
None?
All right, so we did run now we're working off the ECU bundle, and we're starting to draw wires out of the bundle. The first one we wired was for the starter, and we were able to click on the masters because they're working now, and we're able to hear the starter engage. So we got that far. Now we're working on a couple more wires from the ECU bundle, which is really just one wire, and that is the power to the ECU. It does have two wires in it, but we have shortened it just a little bit, but both wires go to the same place, and we're putting the terminal back onto it like we always do. We watch, make sure we got both wires there, and making a real good crimp. We know this is a really serious or important connection because this is the power to the computer that runs the engine when we're up in the sky. So we're going to put that on the main bus for the engine so that we have power to that as soon as we engage the we're going to take that nut off and put that on, and that gives us permanent power to the computer when the battery 1 or battery 2 is on. So that's going to go here. Did you take it out?
No, I did. So Go ahead and tell me what you're doing right now.
Yeah, this is for the alternator. So what we got, now we're going back to that terminal strip we were working on. And basically, again, we're joining wires, which means like right now, I'm adding the wire that comes from the wire loom that came with the engine, this bundle over here. And I'm putting my alternator, engaging the alternator wire to the terminal strip. Now in order to be able to, I'm not going to tighten that too much, to energize it, I have to come on to here from my alternator switch. So the next wire we're going to make up is a wire between the alternator switch, which has already been powered through all of this here. So once we throw this one to here, we flip the switch, we put power into here, blah, 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 goes out to the alternator, and the alternator is engaged. So that's the next wire we're going to make up.